So for taking derivative, and if you have the constant in front, you can simply just put the constant aside, take derivative, and multiply constant back in. So you see right here, for part A, the derivative of 3x to the fourth power. So if I just simply take derivative of x to the fourth, I bring down the 4, and then I have x cubed because 4 minus 1 is 3. Now you see we have the constant in front, so I simply multiply the constant. Okay, so for part B, think of it at this way. So we have derivative -1 times x. What is the derivative of x? So derivative of x is just 1, right? So we have -1 times 1. So it's just simply -1. All right. Now, if you have the sum of the functions and you take derivative, it's simply the derivatives of the sum. So it's really simple, and for subtraction, same thing. So if I have something like example 5, I can simply take derivative of one term at a time. So what I have right here is the derivative is going to be 8x to the 7th power plus 12 times 5 x to the fourth power minus 4 times 4 x cubed plus 10 times 3x squared minus 6. Because derivative of x is just 1, so I'm multiplying the -6. And derivative of constant is just 0. Okay, so what I have is 8x to the 7th plus 60x to the 4th minus 16x cubed plus 30x squared minus 6. And don't forget that for these problems, I know that I write down everything. Eventually, you don't have to. You can just multiply the constant right away. All right, so we want to find the points on the curve where the tangent line is horizontal. So tangent line is horizontal, meaning the slope has to be 0. That's horizontal. Okay, so how do we find the slope of a tangent line? Taking the derivative, right? So the derivative in this case is going to be 4x cubed minus 12 x to the first power plus 0, right? So I'm going to set this one equal to 0 because we want the line to be horizontal. So the slope has to be 0. Now, how do we solve it? You can just simply factor. Okay, so you can see that I have x equal to 0, x equals to, you see for this one, x squared minus 3 equal to 0, x squared is going to be 3, and then you take the square root, you ended up with plus and minus square root of 3. Okay, so we have 3 points. So we have the curve has horizontal tangent. When x equals 0, x equals square root of 3, and x equals to negative square root of 3. So we have 3 different lines. So to find the points, you simply take x and plug it in the original equation. So for example, I'm just going to do the easy one, which is x equal to 0. So when x equal to 0, y is going to be 0 to the 4th minus 6, 0 squared plus 4. So it's just 4. Okay, so the first point is going to be 0, 4. If you do it for square root of 3 and negative square root of 3, we're going to end up with -5 and -5 as well. Moving on to example 7. Okay, so for example 7, you can see right here that we have the motion problems. So S is the measure in centimeter and T in second. We need to find the acceleration as a function of time. And then from there, they're asking you what is the acceleration after 2 seconds. So for these problems, make sure you remember that we have velocity is, so I'm going to call this is S of t. S of t is the motion function. Okay. Now the velocity is going to be S prime. And then I have the acceleration is going to be the derivative of the velocity. Okay, so keep that in mind. Now, let's find the velocity first. So velocity, which is S prime, which is 3 times 2, so 6t squared minus 10t plus 3. So that's going to be the velocity. Now let's take the derivative one more time to find the acceleration. So acceleration is going to be velocity, derivative of velocity. So it's going to be 12t minus 10. Okay, so that's what I have. Now they're asking you for acceleration after 2 seconds. So all you have to do is plug it in. So 12 times 2 minus 10, which is 14. Okay, so that's how you find velocity and acceleration. Okay, let's talk about exponential function. So you see right here, exponential function is defined as b to the x power. Now, we want to look at the e function as well. So if the base, if b is e, okay, the derivative of the e function is going to be itself. So what I have right here, example 8, we want to find the derivative. So the derivative of the e function is going to be e to the x power, and the derivative of the x function is just simply 1, and we have the negative in front, so it's going to be negative 1. Okay, so we have double prime, which is the derivative of the derivative. And in this case, what do we have? We have to take derivative of this, which is the e function, e to the x power, and derivative of 1 is going to be 0. Negative 1, still 0. So we have e to the x function. Okay, so that's going to be the second derivative.